Okay, so in our special triangles, I'm going to go through this number by number, letter by letter. So number 1 is J, 2 radical 3. A lot of these are repeats from the other packet, right? So hopefully that should cut down quite a bit on questions we need to go over. Number 2 is K, 4 radical 5. Number 3 is A, 3. 4 is B, 96. 5 is J, 10 radical 3. 6 is E, 9 plus 3 radical 5. 7 is 16 thirds times radical 3. 8 is B, 18 radical 3. I don't know if I gave letters on 6 or 7, but that would have been E and C. 9 is E, 10 radical 2. Let's see, supplementary angles. 1 is J, 55 degrees. 2 is F, add up to 180 degrees. 3 is G, 140 degrees. Move down to triangle inequality. 1 is E, 11. 2 is C, 117 over 125. 3 is A, 4 pi. 4 is F, always between 20 degrees and 60 degrees. And I think our last two questions here are 5, which is F, the measure of angle X is always less than the measure of angle Y. And 6 is K, segment RS is congruent to segment SM. Okay. Okay, let's start back at the beginning of this and answer as many questions as I can for you. First page 1 and 2. What do we need? 1? Okay. All right. In the figure below, Q lies on PR, angle PQS and angle PSR are each right angles, and the measure of angle QRS is 30 degrees. If PS is 4 units long, how many units long is QS? Okay, so what they're telling me here is I've got a right angle right here. You notice that this question is a repeat from your other packet. I don't know how many of you kind of caught that or not. Okay, but if we notice, it says that this, we have a right triangle right here, correct? Where this angle is 30 degrees, which means what is angle P? If I know that angle S is a right angle, 60 degrees. Okay, and we know that this length right here is 4, which is opposite the 90. So if I take that triangle just by itself, okay, where I'm saying that this is 4 and I'm looking for QS, which is this guy right here, and I know that this is 60, I know that this is 30. All right, the next easiest thing to find is that right there, correct? All right, what is that going to be? Nope. It's opposite the 30. So if my hypotenuse is 4, what's my short side? No, you're going the wrong way. The hypotenuse is always double the shortest side on a 30, 60, 90. So this should be 2, right? Because 1, 2, 1 radical 3, right? So this is going to be what? 2 radical 3. Okay, does that make that a little bit easier? Okay. Oh. Here, let me hit pause on this real quick. Okay. Do you need anything else from question number 1, or does that pretty well hit it for you? Okay, I'm not saying that that's the only way to figure that out, but anyway. All right. Anything from 2? Okay. Go on to the next page, which is just number 3. Okay, I got several on 3. 2, 30, 60, 90. So what I had to start off with here is determining the most likely right angle. Okay, so we've got those, and I put in, kind of my obvious 60s. Okay, my obvious after that 30s. Okay, so that I at least had that information based upon appearances. The hypotenuse of the larger triangle is 18 centimeters long, which means I'm going to put 18 here. If the perimeter of one triangle is 3 times that of the other triangle, how many centimeters long is the shortest of the 6 sides? Well, if I know that this hypotenuse is 18, then I know that I'm going to get 9 right here, correct? Okay, the other thing that they tell me, and I don't guess, maybe I don't really need that per se, but with perimeter and scale factor, perimeter has the same ratio as the scale factor. So if the scale factor is 3 times, right, if the perimeter is 3 times that, then the length of a corresponding side is going to be 3 times. Does that make sense? So what we're saying then is that we can take 18 and divide that by 3. Well, what's 18 divided by 3? 6. All right, which means what I'm saying there is that that hypotenuse is 6. And it says, what is the shortest of the 6 sides? Well, the shortest of the 6 sides would be the side opposite the 30-degree angle on the smaller triangle, right? So I'm just going to take 6 and divide it by 2, right? Which is going to leave me with 3 for right there. Okay, does that sum that up for you a little bit? Okay. Yeah, you have to remember, in similar figures, the ratio of the perimeters is the same as the scale factor. Okay. All right, number 4 or 5? 5, okay. I felt like we'd done number 4 in the other packet. Okay, given the information in the diagram below, including the fact that triangle BCD is isosceles. All right, so the fact that triangle BCD is isosceles and it is right tells me that those two angles are 45, 45, right? Okay, because all isosceles right triangles are 45, 45, 90 triangles. Okay, so I can put 45 in there if I want. All right, what is AB? Okay, well the first thing I need to do is I need to find out what BD is. Okay, so I know that these two side lengths are going to be the same because they're opposite these base angles. Okay, so in a 45, 45, 90 triangle, it's 1, 1, radical 2, correct? So if my hypotenuse is 10 radical 2, well then what are the other two sides? 10. All right, so I know this is 10. More importantly, I know that this is 10 here. So if I know BD is 10, well, what I have here is a 30, 60, 90 triangle where the short side is 10. Okay, which means my hypotenuse would be 20, but I'm looking for this right here. 10 radical 3, right? 10 radical 3. Okay, so it's just a matter of ratios. Okay? That help you out? Okay. Come on. I don't know what I did there, but I don't want it. Go away. I don't know what to do with you. All right. Clear ink. And there we go. No. Okay. This is where we hit pause and try to get it all back again. And we're back. Let's see where we're at. 6, 7, and 8. Haley? 7. Okay, in a 30, 60, 90 triangle, if the long leg has a length of 8 inches, how many inches long is the hypotenuse? Well, if I know my ratios well enough, I don't have to draw it. Okay, because if my long leg is 8, what I'm going to need to do there on a 30, 60, 90 is divide by radical 3. Okay, now let's go ahead and draw it, because I feel like some of us probably do need that. So 60. Okay, the long leg is as opposed to the hypotenuse. So what they're saying is that this is 8. Before I can find the hypotenuse, for me, I need to know what the short leg is. That way I can easily multiply it by 2. All right? But 8 is equal to x radical 3. So I'm going to divide by radical 3. Okay? And you have one of two options. You could go ahead and multiply that by 2 over 1, right? That's going to give you 16 over radical 3, right? Okay, so you could do that, or you could go ahead and simplify the radical, and then, rationalize the denominator, and then multiply by 2. Either way, okay. Normally, probably what I would do is I'd rationalize the denominator, and then go ahead. So I'd have 18 radical 3 over 3 multiplied by 2 over 1. That's going to give me 16 thirds times radical 3. Okay, to get that longest side, or the hypotenuse. Does that make a little bit? Okay. So you can see where these 30, 60, 90, 45, 45, 90s are really important to get down. Okay, 6 or 8? 8. Okay, 8. In triangle ABC, the measure of angle A is 30 degrees. The measure of angle B is 60 degrees. At this point, I want to draw it just to make sure I don't get anything wrong. A is 30, so I'm going to put A up there because that looks the most like my 30. Okay, B is my 60. Which means C is right here. The reason I do that is because they start talking about AB, and if I'm not careful, I'm not going to know what they're talking about, okay, if I don't draw it. Okay, so they tell me that AB right there is 12 units long. What's the area in square units of triangle ABC? Well, 12 is the only thing I can't use to find the area here. But I do know that my 30 side is going to be half of my hypotenuse. So this is going to be 6, which is my base. And my height is going to be 6 radical 3. Right? So I've got 6 times 6 radical 3 divided by 2. Well, that's going to give me 36 radical 3. Right? Divided by 2. 36 divided by 2 is 18 radical 3. That's my area right there. Okay? All right. Let's see. 9. 9. In the isosceles right triangle below, AB is 10 feet. What is the length? If they tell me that it's isosceles, then I know that it's right. So I know it's 45, 45, 90. So I know that this side is also 10. What is the length of AC, which is the hypotenuse? 10 radical 2, right? Once you know how those ratios work, you can fly through a lot of these questions. Okay, now we're getting over to supplementary angles. Just as a quick refresher, what does the term supplementary mean? 2 angles that add up to 180 degrees. And this is going to use some remote interior angles, some of that type of thing. 1 and 2. 1. Okay, in the figure below, PQ is perpendicular to QR. What that's telling me, if 2 lines are perpendicular, then they meet at a right angle. Okay. Let's see. Points Q, R, and S are collinear. It's a straight line across. If the measure of angle PRS is 145 degrees, so that's an exterior angle there. What is the measure of angle QPR? So a couple different ways that you could look at that. One, if these are collinear, then I could take 180 minus 145, get the remaining, what is it, 35 degrees. Okay, so that would tell me that this is going to be 35 degrees here. I know that there are 180 degrees in a triangle. I've got 90 and 35, so that's what, 125 spoken for. So I could take 180 minus 125 and get the remaining 55 degrees. Okay. Okay. Does that work for you? Okay. All right. What about 2? Nobody on 2? Okay. 3. Kind of the same type of thing. In the figure below, angle BAC is 30 degrees. Okay. Angle ABC is 110. And points B and C and D are collinear. What's the measure of ACD? It wants to know what that is right there. Okay, well, take 110 plus 30, which is 140. Find out what's left, right, which is obviously 40 degrees. Okay, if these are collinear, then 180 minus 40, you should get 140 degrees. Right there is what's left. Okay, were we making that a little bit harder than it was, or what were we missing there? Looked at the wrong angle. Oh, wrong 3. So you got that one right. Okay. All right. Let's see. Triangle inequality. 1 or 2. 1 and 2. Just one for you. So, all right. Given a triangle with one side measuring 4 centimeters, the other side measuring 6 centimeters, all the following can be the length in centimeters of the third side except. Okay, so the triangle inequality theorem is based upon this principle, and I don't know if this is a geometry or algebra 2 concept, just because you get to teaching all the classes and forget what you taught where. But this is the rule for triangle side lengths, is that any 2 sides of a triangle have to add up to be greater than the length of the third side. Okay, so if I know that I have 4 and 6, what we're saying here is that the x has to be less than the sum of 4 and 6. Well, 4 plus 6 is 10, so x has to be less than 10. But 4 plus x has to be greater than 6. So it has to be greater than 2. It can't be equal to it. The 2 sides can't add up to be equal to the third side. Do you follow me? Okay, so the math that we start off with is 4 plus 6 equals 10. 6 minus 4 equals 2, and my number has to be between the sum and the difference of the other 2 sides. So as I look at that, the length can be all of them except, well, it can't be 11. 3, 5, 7, and 9 are all between 2 and 10. Okay? So if you understand that, then you can create a range of values that are accepted and then find out what's outside of that. Okay? And number 2. All right, the lengths of a right triangle are 44, 117, and 125. What is the cosine of the smallest of the 3 angles? Well, what you want to know here is that the smallest angle is going to be opposite the shortest side, right? Okay, so the shortest angle, or the shortest side, is 44, so the smallest angle is going to be that right there. Keeping in mind that this is a right angle, so this no matter what, is my hypotenuse. This is opposite to my angle. This is adjacent to my angle because they're asking for a trigonomic function. So cosine equals what over what? Should be adjacent over hypotenuse, right? Adjacent over hypotenuse. So adjacent is 117 over hypotenuse 125. Okay? Does that help you out? And that right angle is really small and be easy to miss. Okay? It doesn't necessarily look like a right angle if you take that out of it. So make sure you're identifying everything. And I do like to label those as opposite, adjacent, and hypotenuse whenever I start. So anytime I'm doing a trig function. All right, number 3. Okay, or was it 4? 3 or 4? 3. Okay. All right. This is in the details. Points A, B, C, and D are on the circle. Okay, with center at X has a radius of 12. The length DB equals the length XB. What is the length in inches of DCB? So they're actually looking for an arc length. Okay, so what we have is what we know is that the radius is 12. So I know that's 12, right? Okay, DX is also 12 because it's also a radius, and they told me that DB was the same as XB. So I know that all these side lengths equal the same thing. And the reason that's important is because I need to know what the angle of DXB is. Well, if that's an equilateral triangle, what are all the angles? They're all equal. It's an equiangular triangle, so the angle DXB is what? All angles of equiangular triangles are the same no matter how big or small. They're all 60 because you're taking 180 divided by 3. So I know this is 60, and I know that my radius is 12. That's important because if I want to find arc length is based upon the formula for circumference times the measure of the angle, and the central angle and the angle of the arc are the same. So I'm going to get 60 over 360. Okay, so in this case, it's 2 pi 12 60 over 360. I really need to change this just so we're getting our formula. But this should be m. Okay, and this is how we're plugging it in. Okay, notice that they're answering it in terms of pi. So 60 over 360 is 1/6. So what I'm getting is 2 times 12, which is 24. 24 times 1 is 24. 24 over 6. 24 divided by 6 is 4. And if I'm answering it in terms of pi, I'm getting an answer of 4 pi. Does that help you out? Okay. Anybody on 4? 4? Okay. Okay. The interior angles of a triangle measuring 20 and 60 respectively, which of the following describes the location of the longest side of the triangle. Okay, so if I have, a 20, sounds not annoying at all, is it? 20 and 60. All right, that's 80 degrees, right? Which means this has to be 100 degrees, correct? Well, the longest side of the triangle is going to be right here. Okay, so it's always going to be the included side between the 20 and the 60 because 100 has to be there. Okay, so that's how I get A for that answer. Okay, let's see. Last couple of questions here, 5 and 6. Ryan? 5. Okay, just so that I know, is anybody needing 6? Okay, so 5's the last question. For all triangles x, y, and z, where xz is longer than yz, such as the triangle shown below, which following statements is true. Okay? The measure of x, the measure of angle x is always less than the measure of angle y. Okay, that is my true statement because what they're telling me is that xz is longer than yz, right? So if xz is longer than yz, then angle y has to be greater than angle x. Okay? Because a longer side will be opposite a larger angle. Okay? So, I mean, we could go through the rest of them and say why they're wrong, but A is the correct answer. Okay, any other questions? Anything that I missed? Okay, anything you want to go back and look at? We do have time. No? Going once, going twice, and we're done. Okay.